Hello. Okay, I'm going to do this example like you would want to, solve this problem if you were taking an exam or something. If you really were solving this problem. So the idea is that we have this situation where we're manufacturing two different types of motorcycles. We've got the 250s and the 150s. And we're given certain information, and the question is how many of each do we build? So, sort of to organize your thoughts. Here, this is what I would do. So, before you start doing any math or worrying about a bunch of equations, you want to organize your thoughts, right? So, typically, what I like to do, I guess, is make a little chart. Okay. So, and I'll just label the things that I want to keep track of, right? So, the first column here will be for the 250s, right? So that's just a label on top. The second column will be for the 150s. Okay. And I'm going to put totals over here, right? Totals over there. So there's some things that they want to know. They want to know how many to make. So that's the number made, right? Okay, and then we have the time. In other words, the assembly time. Right, and that's in hours. Keep track of that. And then there's material cost, right? So if you read through this paragraph, it tells us certain things. For example, it says that it takes 5 hours to build the 250s. So I put that in the second row, I guess third row if you count the labels. So 5 hours it takes to build the 250s, and it takes 3 hours to build the 150s. And then for material costs, for the 250s, it's just $3,400. And for the 150s, we have $2,500. Okay. And we're trying to find some information. So the first thing that we need to do is to assign some variables of what we're looking for so that we can turn this into mathematics. So I'm going to use X for the number of 250s and Y for the number of 150s. Now we can write down some totals. Like, for example, the total number of motorcycles we're going to make, X plus Y, this is just the total number, will be that, right? Total amount of time that we would spend. So if we made X 250s, and if we made Y 150s, we would then do the following, right? The total amount of time would be 5 times X plus 3 times Y. That's how these things are defined, right? 5 motorcycles times the amount of time it takes to make one motorcycle, right, which is 5 hours, is the total amount of time that it takes to make 5 motorcycles. Similarly, the cost would be you take 3,400, right, times the number you make of the 250s plus 2,500 times the number of 150s you make, and that's your total material costs to make X and Y of these. Now, in the description of the problem, we're given a budget, right? And we're given an amount of time that we're able to use. So it says there that we're given $260,000 to spend. So what we want to do now is to start to write down things that we want to be true. We'd like to spend all of it. So it's 3,400 plus the times X plus 2,500 Y. That's equal to, we want that to be equal to, what is it here? $260,000. I'll put the thing in there. I'm leaving the dollars out because I've indicated in the chart that the material cost, that's really, I should put that up there. That would be the material cost in dollars, right? We could be working in different currency. So once you specify the units, then you're allowed to not indicate them in the equations, right? Now the time that we're spending from the information given will be another equation, right? And we want 5x plus 3y. We would like to spend, we have enough money to pay for how many hours? 350. Okay, so what we've done thus far is we've taken a question in the real world and we've now transformed it into a mathematical question, and now we're just going to try to utilize some techniques from mathematics to solve this, and then we'll have the answer to our question. So what we're using here is we're going to eliminate a variable. And many of you have done this, and I would bet that a large percentage of you have done this. So I'm going to replicate that for you, and you will see that we'll use a similar technique in the future. Okay, so what I like to think about, there's this line here, okay? The things on the left, those are just equations. Those are objects in mathematics. The things on the right, over here, these are going to be me keeping track of things. So when I say something to you, I can refer to it. So I'm going to refer to the first true statement as equation 1, okay? And this is equation 2 here. So reading across, this is the first equation, this is the second equation. Now, one of the fundamental things that we can do in mathematics is we know that we can multiply both sides of an equation, for example, by some non-zero number, and we get another equation that has the exact same solution set. See, we're assuming we have these x and y's that we're looking for that satisfy both of these equations. This is a system of equations, and we want to find out what this x and y are. So what I'm going to do is I'm going to eliminate the, I guess I'm going to eliminate the x. Now, what I notice here, I'll grab a calculator, I guess I'll show you how, I do use some technology, right? So let me clear this stuff. So what I'm realizing is I would like to get rid of this variable x. And the way I'm going to do that is I'm going to take my 3,400. I'm just going to divide it by 5 to see that what I get here is that's 680 in scientific notation. So what I'm going to do first is I'm going to multiply both sides of equation 2 by 680. Okay? So watch that. I'm going to denote that over here. So I'm going to take 680 times, this is my little notation for this, equation 2, and I'm going to write it right here in this line. Now, if I do that, I get 3,400 times x plus, now let's see, if I take, let's see, what is it? What is 680 times 3? I'm just grab my goofy calculator again. So if I do that, I'm going to take my, now I have to take 3 times 680, and what is that? Okay, that's 2, sorry for the scientific notation, all right? So that's 2,040, right? Times y. Now that has to be equal to, well, now I'm going to take and multiply my last thing here, 350, right? So 350 times whatever I get here. Where's my multiplication thing? Okay, times 680. And that's going to be equal to, okay, there we go. That's 238,000 period. No units. Okay. Now watch this. As a result of doing this, there's another nice fact in mathematics that you've studied, that you can add if you add something to both sides of an equation that are the same, you get another equation with exactly the same solution set. So watch this. I'm going to add actually the negative of this equation right here to both sides. So what I'm going to write here, I'll just put it here. I'm going to put equation 1, and I'm actually going to write it this way as minus 680 times E2. And this is the idea of eliminating a variable, because watch what we get. If you do that, when I add 3,400x and I subtract 3,400x, there are no x's left over, right? And now when I take 2,500 minus 2,040, I get 460y. Well, that's now has to be equal to what I get when I take 260,000 minus 238,000, and that leaves me with 22,000. Okay, So now what I can do is I'm going to take this equation, and I'm just going to, I'll really shorten the notation. I'm just going to divide both sides by, of the previous equation by 460, leaving me with the following equation, that y is equal to 22,000 divided by 460. And that's one of the things we're looking for, right? We now look back at our chart. Y is the number of 150cc motorcycles that we're going to produce so that we satisfy both of these equations, right? And now to find x, I'm going to use equation 1 here. Okay, so I'm going to use equation 1, meaning I'm going to replace the value of y that I have found in equation 1 and then solve it. Okay, so let's do that. I'll just write this down. So I get 5 times x plus 3 times this quantity for y divided by this, right? This is equal to 350. You can go back up there and look to see that I have actually used, oh, what equation did I use? I actually used equation 2 because the numbers are smaller. You can use any equation you like. I just mislabeled them. So I use equation 2, see that? 5 times x, which I don't know, plus 3 times y, which I now do know, is going to be equal to 350. Now, let's solve this equation for x, okay, and I'm just going to do that, assuming that we can all do that at this point. So 5x would then be equal to 350 minus this 3 times 22,000 divided by 460. And then I'm going to divide both sides by x, and I get my answer, which is 350 minus 3 times 22,000 divided by 460, and that is all going to be divided by 5. Okay, now is a good time to bring in some technology. One of my big models, I guess, I follow is that I never really use any technology until I've actually represented the answers, right? I could have done all this by hand, except for maybe, like, what's the hard part here? I guess dividing 3,400 by 5 would have given me some trouble. But so you can use technology to decide what you're going to do. But in the end, it's really good to just take your algebraic expression and pop it into your favorite piece of technology and push the button. So let me show you here. So to give you an example of what I mean by that, let's take out our calculator. And I highly recommend that if you're going to use a calculator, you use one that you can basically type stuff into. So I'm going to use this one right here. Okay. So I'm just going to type this in. So let's see, I'm going to take 350. I'm going to subtract 3 times, I'm going to use a bracket here because it's going to be 22,000, right? And I'm going to divide that by 460. Okay, I'll put another bracket around that. Now I've putzed with this. One thing I highly recommend that you do, otherwise you should stay as far away from technology as possible, is to make sure you understand how your technology works. You see, I want to put another bracket in there, right? So watch this all. Whoa, hold on now. Okay, now I want to put a bracket there, right? Then I'm going to go all the way over to the other side, right? Okay, and I'm going to put another bracket because now I'm going to divide by 5, right? Okay, now watch this beautiful thing. So if you look at what I wrote with my bare hands up top there, and if you look at what's appearing in my machine, I can look and see that they're identical, right? And if you have a good understanding of mathematical notation, this will never be a problem. So I'm just going to hit now I'm going to put faith in this calculator, boink, and I come up with this number. So it tells me that, here, I'll put this off the screen here so I can read it. So it says that x, now I'm reading from my thing here, is actually equal to 41, and then I'll use decimal notation, 304348. Okay? Now, Now at this point, doing another calculation, y is equal to, and this is an approximation, shame, right? That's not quite right. Of course it's an approximation. We're making motorcycles. This is even an approximation to the solution of the system of equations, but moreover, it's certainly not it's an approximation to our question. So what does y, and I'm fumbling through my papers because I actually worked this out here. Okay, so if you do the same thing with a calculator, you get y is about 47.7826. Now, okay, now you go back and it's an approximation. Now, since this is the real world, right, we have to give an answer to somebody. So the idea here is that we'd like to spend, right, this $260,000. So you might say, well, let's just let, right, let's let x equal, maybe 41, right? And y, let's set that equal to 48. In other words, you want to round up, let's call y twiddles, they're different. Round up to to an answer that makes sense. If you do that, and if you see how much that would cost you, then you would be spending $259,000, I did this earlier, $400, right? So that's close. You might say, well, no, let's really just do x bar or whatever twiddles equals, maybe run around this one up, 42, right? And then y would then, let's see if we round that one up. We might as well round the other one down because we don't want to spend a lot more, so we take 47, right? And let's see, I think I did the calculation here, you see, and if you do that, then you're going to be spending a little bit more, right? 260,300 or something like that. Okay, so the point is, let's see if that makes sense. If you make more of y, should that cost more? Yeah, well, I don't know, that doesn't seem to make sense. No, I guess you're making, watch this. So if you rounded x up, right, from the actual solution, that means the things that are more expensive to make, you're making more of those. And the things that are less expensive to make, you're making less of them. So the number should go up, and that's why our approximation goes off to 260,300. If you make less, you'd spend less. So the answer is, okay, we're going to make like 48 of the big ones and 41 of the small ones. So this is how you would use mathematics to get some idea of how to solve a real world problem. So I hope this helps you. If you have any questions, make sure to send me an email or we'll discuss this. Okay, thank you.